In this lesson, we're going to continue to look at the different ways in which we can use to determine the number of moles of a substance. So in the last lesson, we have looked at what is a mole. A mole is a unit of quantity, and the quantity that it represents is 6 times 10 to the power of 23. Alright, how do we obtain the value of moles? There are 4 different ways. So depending on what is given to us, we can use the respective methods. So in the last lesson, we have looked at if we are given number of particles, alright, we can actually find number of moles by taking number of particles divided by Avogadro's constant. Alright, the triangle that we were looking at looks something like this. Alright, if we are given mass of a substance, we can actually find number of moles by taking mass divided by the molar mass. Okay, so number of moles equals to mass over molar mass. Right, once again, molar mass is the mass of 1 mole of a substance. So this lesson, we're going to look at 2 other methods. Right, one in which we are given volume of a gas. Alright, the other one where we are given volume of a solution. Alright, so in a question, you need to, if a volume is given to you, you need to be very sure whether it is talking about a gas or a solution. Now, if we are given volume of a gas, alright, how do we find number of moles? Before that, we need to define a new term, the last one for this part, molar volume. Now, as mentioned, molar simply means for 1 mole. Okay, so molar volume simply means the volume of 1 mole of a gas. Alright, and there's one very important concept that we need to learn here. It's called Avogadro's law. Now, long time ago, this scientist named Avogadro, he found out that 1 mole of any gas, right, any gas, be it carbon dioxide, nitrogen, or the gas that comes out when you pass motion, alright, 1 mole of any gas, it actually occupies the same volume regardless of the gas that we are looking at. Alright, and that volume is 24 dm cube at room temperature pressure. Now, some of y'all may not be familiar with the unit dm cube. Okay, dm cube, 1 dm cube is actually equals to 1000 centimeter cube. Now, this conversion is very important. Reason being, later you will see in many calculations the volume of gases are given in centimeter cube. Alright, so you need to remember to make the conversion. Alright, so before we go on, I'm going to repeat Avogadro's law again, that 1 mole of any gas, be it nitrogen, carbon dioxide, oxygen, helium, alright, any gas, if I have 1 mole of that gas, it will have a volume of 24 dm cube. So now, once again, we'll look at some simple mathematical questions and use the questions to derive the formula or the relation between number of moles and volume. Okay, in the first question, what is the volume occupied by 3 moles of helium gas? Okay, for that we need to invoke Avogadro's law. 1 mole of helium, alright, would occupy a volume of 24 dm cube. Alright, so if I have 3 moles of helium, what volume will it occupy? Okay, the volume of helium will actually be equals to 3 times 24, meaning the volume of a gas is equals to number of moles times the molar volume, alright, which I will represent by the symbol V subscript M. Okay, so let's move on to the second question. What is the volume occupied by 3 moles of oxygen gas? Alright, you may be wondering, hey, is there any difference? Now we were looking at helium versus oxygen. Alright, so let's ignore the helium first. Let's look at oxygen. So if I have 1 mole of oxygen gas, by Avogadro's law, it will occupy 24 dm cube. So if I have 3 moles of oxygen, what volume will it occupy? Again, I will take 3 times 24, Alright, and that will be number of moles times molar volume again. Alright, so what I'm trying to show here is this, that no matter whether we are looking at helium, alright, or we are looking at oxygen, as long as we have the same number of moles of the gas, it will occupy the same volume. Okay, and now to the last question, how many moles of nitrogen are there in 12 dm³ of a gas? Alright, so over here we know that 1 mole of nitrogen occupies a volume of 24 dm³. So how many moles of nitrogen will actually occupy 12 dm³? So for that, to find number of moles of nitrogen, we need to take the volume divided by the molar volume. Okay, so over here this is 0.5, and the formula involved would be volume divided by molar volume. Alright, so from this simple problems, we can actually establish the relation between number of moles, volume, and molar volume, which looks like this. Okay, so if you want to find number of moles, it will be volume divided by molar volume. If we want to find volume of a gas, it is actually number of moles times molar volume. Now let's practice. So again, I'm going to draw the triangle. Find the volume occupied by 0.1 moles of chlorine. Okay, so volume, now I want to find volume, is actually equals to number of moles times molar volume. Right, so for the first example, I'm going to take 0.1 times 24, so that will be 2.4 dm³. That's the volume of chlorine. Okay, 0.75 moles of oxygen will have a volume of 0.75 times 24, which is 3/4, so 18 dm³. And lastly, I have 5 moles of sulfur dioxide, so the volume will be moles times molar volume, and that will give me 120 dm³. Okay, now in this question we are given the volume, we need to find number of moles. So how do we do that? From the triangle, if we want to find number of moles, alright, we need to take volume divided by molar volume. Alright, so in the first example, to find number of moles of CO2, I take volume, which is given as 2.4, divided by molar volume, which is 24, so it's 0.1 moles. Number of moles of ammonia, the volume is given as 12 dm³, so molar volume is 24, number of moles is 0.5. Okay, the last one is the most important in this example. Alright, if you look at the volume of nitrogen given, is given as centimeter cube. Alright, in fact, when we collect gases in the lab, most likely the volumes that we encounter will be in centimeter cube rather than dm³. Okay, so in this case, the common mistake that students will make is this, that they will just take 72 divided by 24, right, which is wrong, because 72 is in centimeter cube and then 24 is in dm³. Alright, so the correct one is to convert your dm³ into centimeter cube first. Alright, so the correct working should be 72 divided by 24,000, and that will give us a value of 0.003 moles. Okay, so once again, whenever you see volumes of gases, you need to check whether it's given in cm³ or dm³, and you need to convert accordingly. Now the last method for obtaining number of moles is for when you're given volume of solution. Alright, before we go into how to perform the calculation, let's recap what is a solution. We have learned in element compounds and mixtures. Alright, when we have a solid, for example, when we have a salt, alright, when we have salt and then we add it into water and then we stir it, what we get is a salt solution. Alright, because your salt is going to dissolve in water. Now there are some terms that we need to recap. The salt over here, or the solid that dissolves in the water, the solid that dissolves in the liquid is called the solute. Alright, and the liquid that's used to dissolve the solid is called the solvent. Alright, and when you when the solute dissolves in the solvent, the thing that's formed, the mixture that's formed, is called a solution. Okay, so in order to perform calculations for volumes of solution, we need to know something called concentration. Alright, concentration is the amount of solute, meaning the solid, dissolved in 1 dm cube of the solution. Alright, so for example, if I have a salt solution, in the concentration is the amount of sodium chloride that's dissolved in 1 dm cube of the solution. When I say amount of solute, I could mean the mass. Alright, so the mass of solid that's dissolved in 1 dm cube of solution, or I could mean the number of moles. So the number of moles of solid that's dissolved in 1 dm cube of solution. Therefore, there are two units that we can use for concentration. If we are talking about the mass of solid, then it's grams per dm cube. If we are talking about number of moles of the solid, it is mole per dm cube. Okay, so now imagine if I have a solution of sodium chloride, right, a salt solution which has a concentration of 0.1 mole per dm cube. Okay, so now if I have if the volume of solution is 2 dm cube, alright, so how many moles of sodium chloride do I have in the solution? I can actually take 0.1 times 2, alright, which is essentially the concentration, which I'm going to represent with the symbol C, times volume. Alright, so from there we can actually construct a relationship between number of moles, concentration and volume as follows. So number of moles equals to concentration times volume. So in the event where we need to find concentration, is actually equals to number of moles divided by volume. Alright, now let's try to apply the formula that we have just learned in this example over here. So I'll construct the triangle. In this case, we are given the concentration of sulfuric acid as 0.25 moles per dm cube. Okay, in the first part, we are asked what is the concentration of the acid in grams per dm cube. Right, recall that concentration can be expressed either as mole per dm cube or grams per dm cube. And now, how do we convert from mole per dm cube to grams per dm cube? There's actually a trick. Okay, mole per dm cube to grams per dm cube. How do we convert between the two units? The trick is to ignore the dm cube. Alright, what do I mean by that? So how do we convert? If we are given number of moles of a substance and we need to find the mass, we need to find how many grams is it. How do we do it? We need to just multiply by your molar mass. Alright, similarly, if you are given the mass of a substance, you are given the number of grams of it, and you need to find number of moles. How do you find it? Is to divide by your molar mass. Alright, so the trick to convert between mole per dm cube to grams per dm cube is to ignore the dm cube. Alright, and think about how do you convert from moles to gram. Right? How do you convert from grams to mole? Alright, so in this case, to get concentration of the acid in grams per dm cube, I need to multiply the concentration in mole per dm cube by the relative or by the molar mass of sulfuric acid. So that will give me a value of 24.5 grams per dm cube. Okay, so in the next part, what is the mass of sulfuric acid in 25 centimeter cube of the acid? This is again like a mathematics problem. So I have 24.5 grams of sulfuric acid in 1 dm cube of solution. So now, what is the mass of sulfuric acid in 25 centimeter cube? So to find that, the mass of sulfuric acid is actually equals to 25 over 1000 times 24.5. And that will give me a value of 0.6125. And in science, it's a good practice for us to round our final answers to 3SF. Okay, so there. So we have looked at the 4 different ways in which we can obtain number of moles, and it depends on what quantity is given to us in the question. Alright, if we are given number of particles, right, number of moles is actually equals to number of particles divided by Avogadro's number. Okay, the relevant triangle will look something like this. If the question were to give us mass, then number of moles equals to mass divided by molar mass, and the relevant triangle will look something like this. If the question gives us volume of a gas, alright, take note, volume of a gas, then we need to take the volume divided by the molar volume. Okay, and the triangle looks like this. Or if we are given volume of a solution, okay, volume of solution, then to find number of moles we need to take concentration times the volume of solution. So the triangle will look something like this. Alright, so there are 4 different ways to find number of moles of a substance depending on what quantity is given to you. Alright, do take note whenever you are given volume to check whether it's volume of a gas or volume of a solution. Very often students will mix up between the two, especially for tricky substances like, for example, ammonia. Okay, ammonia can be a gas or ammonia can be a solution. Alright, so take note in the question whether it is a gas or it is a solution. That will require different formulas in order to compute number of moles.